Welcome to Newton's inertia beads investigation. This is an effective way of demonstrating and seeing several scientific principles in action, one of which being inertia. According to Newton, inertia is the tendency of all objects and matter in the universe to remain motionless in the first place, or, if moving, to continue moving in the same direction and at the same speed unless acted on by some outside force that can slow them, stop them, or change their direction. For the demonstration, the beads are loaded into the beaker, with care taken to ensure that they are not tangled. Once the beads are loaded, raise the beaker and then quickly toss the end of the string of beads up and over the edge using a fast pulling motion. Instantly, the beads will start to climb up and over the side of the container. The weight of this starter section of beads will be enough to pull the rest of the beads out of the container completely. You can see the fountain of beads flows from the first into the second beaker. As the speed picks up, the string will rise slightly above the rim of the beaker due to the inertia of the moving beads. You can see this even more clearly in this slow motion video. So, what was happening? Well, thanks to gravity, lifting the container higher off the ground loaded potential energy into the beads. The initial tug that you gave to start the beads flowing was all that was needed to turn the potential or gravity stored energy into kinetic or motion energy. As the speed of the flowing beads increased, you probably noticed that the string of beads actually lifted slightly above the rim of the container due to the inertia of the fast moving beads. What I found was that the greater the mass of beads being used, the greater the arcing effect occurred. When the beads are sat in the beaker, they are experiencing inertia. They're not moving. And except for the fact that we then throw the beginning of the chain of beads over the edge of the beaker, they would stay there indefinitely. It's not to say gravity is not acting on them, but there's just nothing's going to happen to them because they're sat at the bottom of the beaker. Now when we throw the chain over the top of the beaker, then gravity is able to act on this chain, and you can see the chain runs all the way down into here, and this is because it is being pulled by gravity. Gravity is moving in that direction, or the force of gravity moves in that direction, as does the chain of beads. Now the beads in here now start to travel upwards. They're still affected by gravity, but obviously the weight of the beads from here to here is far greater than the weight of beads from here to here, and therefore the imbalance of forces means that the beads will continue to flow out of the beaker. So now to try and explain this arcing. Imagine the chain is a series of links. Well, it is a series of links. And on these series of links, so if I draw a couple of examples of here, as they come up, what happens is, as they get to the top of the beaker, they start to rotate. And this rotation on its own would have little effect if they were just an individual link travelling in this particular range of motion. However, when you think about this link here, it's joined to the link next to it, and that rotation will have an upwards effect, will create or transfer an upward force onto the link next to it. And this transference of these upward rotational forces cause the chain as a whole to arc above the lip of the beaker rather than just flowing straight over it. Now, the heavier the chain, or the larger the balls in the beads that were used in the chain, the larger this arc ends up being. But that is effectively why we have this arc. We have this arc because of the rotational forces of the individual links. Anyway, please try this for yourself. Explore using different size beads and or different beakers and even different heights from which you're dropping them. Enjoy.